From the USGS to talk a little bit more about the earthquake that was felt along the California-Nevada border.
According to a new study, a major source of water for California could disappear in the next 25 years.
The sudden escalation of seismic unrest at the Long Valley Caldera has ignited a wave of concern and scientific focus as the USGS issued a rare red alert following a surge of mysterious earthquakes rattling the region. Long Valley, nestled in eastern California near the Sierra Nevada, has long been on the radar of volcanologists because of its status as one of the largest calderas in North America. But such a dramatic change in seismic activity has elevated its profile to global attention. The red alert designation is reserved for significant hazards that pose immediate or serious risk, and in this case it underscores the sheer intensity and uncertainty of what is unfolding beneath the surface. Unlike smaller seismic swarms that have occurred in the past, this sudden clustering of earthquakes points toward deeper processes that remain enigmatic yet potentially consequential. Before we start, smash the like and subscribe buttons for more updates. The caldera itself, a massive depression formed by a cataclysmic eruption some 760,000 years ago, has always been regarded as a sleeping giant. Its sprawling landscape, stretching roughly 20 miles long and 11 miles wide, tells the story of immense geological power and resilience. While millions of people visit the region every year to enjoy mammoth lakes, hot springs, and ski resorts, many remain unaware of the volatile forces that lurk beneath the ground they walk on. The recent surge of earthquakes, however, has reminded both scientists and locals that the caldera is far from dormant. Every tremor and shockwave carries information about subterranean pressures, magma movement, and shifting tectonic forces that could potentially alter the stability of the entire region. The term mysterious is particularly fitting because despite decades of monitoring, not all swarms of earthquakes in volcanic regions are fully understood. Some arise from hydrothermal activity, where superheated water and gases move through fractured rock, while others may be linked to the slow ascent of magma exerting pressure on the crust. At Long Valley, the current surge seems to defy the patterns of routine seismic unrest. Clusters of small to moderate earthquakes have appeared in rapid succession, spreading across a network of faults that interlace the caldera's floor and its surroundings. The timing, density, and magnitude of these quakes have caused experts to reassess their models and projections, knowing that even subtle changes could signal the prelude to more significant events. When the USGS raises the alert level to red, it represents an acknowledgement that the situation has entered a critical phase. For Long Valley, such a move is not made lightly. It signifies that seismicity is not only intense but sustained enough to indicate something more than random tectonic jitter. While the caldera has produced earthquake swarms before, the difference lies in the scale and persistence of this episode. These quakes are not isolated. They are part of a broader pattern that suggests deep processes are active, shifting, and pressing against the crust. This, in turn, forces scientists and emergency planners to consider the multiple hazards tied to volcanic and seismic unrest, ground deformation, gas emissions, and in the most extreme scenario, the potential for renewed volcanic activity. The scientific community has always kept Long Valley under close watch because it represents a unique intersection of seismic and volcanic hazards. Unlike isolated volcanoes such as Mount St. Helens or Mount Rainier, Long Valley is a caldera system, meaning its eruptions historically were not mere lava flows but massive explosive events that reshaped landscapes on a continental scale. Though it has not experienced a super eruption since its birth, its subsequent history includes smaller eruptions, hot spring activity, and consistent seismic swarms. The recent surge has reinvigorated debates about what lies ahead. Could the caldera be building toward another phase of volcanic activity? Or are these tremors simply the restless breathing of an ancient system that never fully goes silent? From a geological perspective, every earthquake in Long Valley is like a probe into the Earth's crust. The depth, magnitude, and frequency reveal how stress is being redistributed underground. Some of the quakes in this surge have been shallow, hinting at crustal fractures adjusting to internal pressures. Others have originated deeper, raising questions about whether magma is pushing upward or if tectonic plates in the region are grinding against one another in ways that release energy sporadically. The uncertainty lies in distinguishing whether this surge is primarily tectonic, hydrothermal, magmatic, or a combination of all three. The term mysterious encapsulates this puzzle because despite modern instruments and decades of data, the subterranean dynamics remain partly veiled. The implications of such seismic unrest extend beyond the geological. Communities living near the caldera, particularly around Mammoth Lakes, have always balanced the beauty of their surroundings with the knowledge of potential hazards. Tourism thrives because of the mountains, lakes, and recreational opportunities, but seismic surges remind residents and visitors alike that the ground beneath them is dynamic and volatile. For local officials, a red alert forces immediate consideration of contingency planning, communication systems, and public awareness campaigns. Even without eruption, prolonged earthquake swarms can cause damage to infrastructure, destabilize slopes, and create cascading risks such as landslides. The psychological impact is equally profound, as the specter of living on a restless caldera weighs heavily during times of heightened alert. For scientists, this red alert serves as a pivotal moment in advancing understanding of caldera systems. Long Valley has long been a natural laboratory for studying the interactions between magma chambers, fault systems, and hydrothermal processes. The current surge provides a rare opportunity to gather high-resolution data in real time, using seismometers, GPS instruments, and satellite imagery to measure ground deformation. Any uplift or sinking of the caldera floor could reveal whether magma is intruding into new areas or if fluids are redistributing in ways that weaken the crust. The ability to capture these dynamics as they unfold is invaluable, though it also underscores the urgency of interpretation. Decisions about public safety and hazard response may hinge on how this data is understood. The broader context of volcanic systems also plays into the gravity of the red alert. Long Valley is one of a handful of supervolcanoes on Earth, alongside Yellowstone and Toba, which are capable of eruptions with global consequences. While no one suggests that a supereruption is imminent, the fact that such systems remain active millions of years after their formation highlights their persistent potential. Every surge of earthquakes is a reminder that these geological giants continue to shape the Earth's surface and climate in ways that defy human timescales. For those monitoring the caldera, the challenge lies in balancing caution with realism, ensuring that public communications neither minimize the risks nor sensationalize them. The mysterious surge also invites reflection on the interconnectedness of Earth's systems. Earthquakes in one area can trigger stress changes in neighboring faults, creating ripples of instability that spread outward. At Long Valley, the caldera sits near the eastern edge of the Sierra Nevada, where the crust is stretched and fractured by broader tectonic processes shaping the basin and range province. This means that the earthquakes are not occurring in isolation, but are part of a much larger geological framework. Understanding how the caldera interacts with regional faults could reveal why the current surge is so pronounced, and whether it foreshadows adjustments across a wider area. What makes this moment so captivating is the sheer unpredictability of what comes next. The surge could taper off, fading back into the background noise of Earth's ceaseless rumblings, or it could persist, escalate, and reshape the caldera's future in ways no one can fully predict. This uncertainty is both unsettling and fascinating, a reminder of the limits of human knowledge when faced with the complexity of planetary forces. For now, the red alert stands as a symbol of vigilance, a declaration that something unusual and potentially significant is underway at Long Valley. Every tremor adds another piece to the puzzle, pushing scientists to peer deeper into the hidden architecture of the caldera and compelling communities to acknowledge the ever-present dialogue between human life and Earth's restless geology. The tremors shaking the Long Valley caldera have grown into more than just geological signals. They have become a narrative of raw planetary energy pressing against the boundaries of human understanding. The red alert designation amplifies this narrative, serving as both a warning and a call to exploration. It signals that the seismic surge is not ordinary background activity, but rather something extraordinary. A sequence that has disrupted the expected rhythm of the Earth in this region. To scientists, it is both thrilling and unsettling. To communities nearby, it is a reminder that their daily lives rest atop a vast chamber of forces capable of rewriting landscapes. What makes this surge so compelling is the intensity with which it unfolded. Earthquakes did not arrive as isolated incidents, but as rapid clusters, many striking in bursts that rattled the ground repeatedly over hours. Seismometers captured waves of energy rippling outward from different depths, each one hinting at processes concealed far beneath the surface. For volcanologists, the most crucial factor is the pattern. When quakes appear in swarms with sustained energy release, they often suggest that fluids or magma are migrating, applying stress in ways that accumulate rather than dissipate. The mystery lies in discerning whether these movements are ephemeral or whether they mark the beginning of longer-term changes within the caldera. The Long Valley Caldera holds a unique position in American geology because of its immense size and violent history. Unlike smaller volcanic craters that result from modest eruptions, Long Valley was carved in a singular, catastrophic event that expelled thousands of cubic kilometers of material. The magnitude of that eruption shaped not only the immediate landscape, but also the broader climate of the region, scattering ash across North America. When one looks at the serene meadows, alpine lakes, and tourist lodges that now fill the valley, it is almost difficult to reconcile the present tranquility with the caldera's apocalyptic origins. Yet the surge of earthquakes has made it impossible to ignore that the forces that created Long Valley remain active. One of the most intriguing aspects of the current situation is the interplay between tectonic and magmatic forces. California is already one of the most seismically active places on Earth, with faults crisscrossing the state and the San Andreas system dominating public awareness. But Long Valley represents a fusion of tectonic instability and volcanic potential. The crust here is thinner than in many other regions, stretched by geological processes that widen the basin and range to the east. That thin crust is more susceptible to deformation, making it easier for magma or hydrothermal fluids to exploit weaknesses. When earthquakes erupt in swarms, they often follow fault lines or zones where pressure is uneven, and the caldera provides a vast canvas for these adjustments to play out. The current red alert, while not implying imminent eruption, does demand careful consideration of the potential hazards that might arise from ongoing unrest. Ground deformation is one of the primary concerns. If magma is intruding upward or fluids are being redistributed, the surface could begin to lift, tilt, or crack. Such movements may not always be visible to the naked eye, but sensitive instruments detect even centimeters of change. These subtle shifts can destabilize infrastructure, alter the flow of groundwater, and modify the natural hydrothermal systems that attract visitors to the region's hot springs. In extreme cases, ground deformation can set the stage for eruptions by creating pathways through which magma may escape. Another dimension to the surge involves volcanic gases. When seismic activity increases in caldera systems, it can fracture rock layers that normally trap gases like carbon dioxide or sulfur dioxide. Once released, these gases can seep into the atmosphere or accumulate in low-lying areas. The Long Valley region has a known history of such emissions, with carbon dioxide occasionally pooling in depressions at concentrations lethal to vegetation and dangerous to animals or humans. With a red alert in effect, the likelihood of gas emissions becomes a pressing concern, requiring constant monitoring to prevent accidental exposure. The broader implications extend to the interconnectedness of volcanic systems worldwide. Scientists often compare activity at Long Valley with that at Yellowstone, another supervolcano in the United States, or with other calderas such as Campi Flegrei in Italy. Each system has its own unique characteristics, but all share the potential for sudden changes that challenge the limits of prediction. Data from Long Valley not only serves the immediate purpose of hazard assessment, but also enriches global understanding of how large calderas behave. By studying the patterns of seismicity, deformation, and gas emissions here, researchers refine models that may one day allow them to anticipate similar surges elsewhere with greater precision. This surge also forces reflection on human vulnerability. Cities and towns across California are already accustomed to preparing for earthquakes, but the dynamics of a caldera system introduce additional layers of risk that go beyond structural safety. Roads may be blocked by landslides, power lines disrupted, and water supplies contaminated by shifts in underground chemistry. Tourism, a major economic driver in Mammoth Lakes, could be disrupted not by disaster itself, but by the fear of potential hazards. The psychological stress of living with uncertainty, of waiting to see whether tremors subside or escalate, is itself a burden that weighs heavily on residents and emergency planners alike. The red alert represents more than a technical status. It is a communication tool that shapes how communities respond. It emphasizes that vigilance is required, that conditions are unstable enough to warrant preparation rather than complacency. For scientists, the challenge lies in delivering this message without causing panic. Volcanic and seismic systems do not operate on human timelines, and many red alerts eventually de-escalate as activity subsides. Yet the potential consequences of ignoring such signals are far too severe. Balancing urgency with reassurance is part of the delicate dance that officials must perform as they interpret the significance of the earthquake surge. The cultural dimension of Long Valley's unrest should not be overlooked. Humans have always lived in proximity to volcanoes, drawn by fertile soils, mineral resources, and scenic beauty, even as they feared the destructive potential of eruptions. Indigenous stories, historical accounts, and modern scientific records all testify to this duality of attraction and danger. In Long Valley, the red alert becomes part of a longer narrative about coexistence with a volatile Earth. Each earthquake is not only a geological event but also a cultural marker, reminding us of the fragile balance between human ambition and natural power. From a scientific standpoint, the mysterious nature of this surge underscores how much remains unknown about caldera systems. Despite satellites, seismometers, and computational models, the inner workings of magma chambers and fault networks remain partly hidden. Seismic waves provide only indirect glimpses, and interpreting them requires a combination of physics, chemistry, and geological intuition. The red alert is therefore not only a statement about risk, but also an admission of uncertainty. It acknowledges that while much can be measured, not everything can be predicted, and that the Earth retains the capacity to surprise even the most advanced observers. This element of uncertainty fuels both anxiety and curiosity. For researchers, it sparks the desire to install more instruments, refine models, and gather every shred of data that might illuminate what lies beneath the caldera. For residents, it heightens the urgency of staying informed, checking updates, and remaining prepared. For the wider world, it serves as a reminder that our planet is dynamic, restless, and capable of sudden shifts that defy the routines of daily life. The Long Valley surge is not just a local event, it is a global signal, echoing the constant dialogue between human civilization and the Earth's inner forces. Looking forward, the next steps involve relentless observation. Scientists will continue to map aftershocks, track ground movements with GPS stations, and analyze gas samples for anomalies. Satellite imagery will be scrutinized for hints of uplift or thermal hotspots, and every new tremor will be cataloged to refine understanding of the sequence. Emergency officials will rehearse evacuation protocols, update hazard maps, and ensure communication systems are resilient in case conditions worsen. These efforts represent the intersection of science and policy, where data transforms into decisions that protect lives and sustain communities. Perhaps the most striking implication of this surge is the reminder that Earth's history is punctuated by cataclysms and that such cataclysms remain possible even in the modern age. The serene landscapes of the Sierra Nevada, dotted with cabins and ski lifts, overlay a geological history of explosive violence. The red alert is not a prophecy of imminent doom, but it strips away any illusion that the forces which created the caldera are dormant. Instead, it emphasizes that they are active, restless, and capable of shaping the future in ways both subtle and profound. The surge has also reinvigorated discussion about resilience. Communities across the globe face natural hazards, hurricanes, tsunamis, wildfires, but calderas present a unique test because their rhythms are slow, deceptive, and difficult to read. Preparedness must therefore operate on two levels: immediate responses to current alerts and long-term strategies that accept ongoing uncertainty. For Long Valley, this means investing not only in monitoring equipment and emergency plans, but also in public education that fosters awareness without inducing fear. Knowledge, after all, is the most powerful tool for navigating life atop a restless caldera. As the earthquakes continue to ripple through Long Valley, they write a story that is as much about humanity as it is about geology. It is a story of curiosity, caution, resilience, and awe. The red alert crystallizes this moment in time, marking it as significant, mysterious, and consequential. Whether the surge fades into memory or develops into something larger, it has already reshaped perceptions of Long Valley, reminding the world that beneath the quiet beauty of Eastern California lies a force both ancient and enduring, waiting in silence until the Earth decides to speak again. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on USGS Red Alert at Long Valley Caldera? We want to hear from you. Thank you for watching, and see you next time.